Talked about how like we're going to go in 2 dimensions now, and when our resultant vector is just like an overall thing, so like a velocity in this direction, this angle. Talked about the x and y components of it, and then we talked about friction.
Yeah.
So exciting.
My favorite.
And this is why friction is so important. Why you need to have this understanding of what friction is and how friction works. Because of everything we've done so far, everything has been on like a flat plane. So like, let's say I have a table, I put a physics book on it, and like a free body diagram of this. So like, what's going on? So like, there's the center of mass, and so then out from it, you have the force of gravity. You go straight down. And then also along with that, we have the normal force that opposes it. But the difference comes in here where we were talking, and I said, whenever we first talked about the normal force, how it's always perpendicular to the surface.
Yep.
And how we discussed that, this is why it matters. So let's say we change everything. I no longer am sitting on a flat plane. Let's say I'm on some ramp. And I set the physics book on the ramp. So we now can do a free body diagram of this. Here's the thing. Force of gravity is still going down, but force of gravity is always straight down. That did not change. So it's still straight down.
That don't look very straight.
I know, I did not use a straight edge.
It's in a general direction.
That's a little line though. Usually the little line's pretty straight.
I looked it up. By the way, congrats to everybody on your superlative.
Thanks.
Now here's the change. So let's say we raised this, and this was on a ramp that is 15 degrees. The normal force is no longer straight up. We've changed it. It's perpendicular to the surface.
We've changed the game.
Oh, I don't like this.
So now,
Whoa.
force of gravity,
What degree angle is this?
15. So now the normal force and the force of gravity are no longer directly opposing each other. So then you have another question. You have another force going on here. We have friction. Now this is the thing. As the problem is set up right now, I'm not applying a force to the book. So, what direction does the force, what direction does the book want to go?
Down.
So it wants to go down the ramp, right? So where's friction?
Does it apply the opposite?
Opposite direction.
Opposite of motion. So since it wants to go down the ramp, we have force of friction going up the ramp. Now you got to look at something. Is the book moving or is it not moving? Why does it matter?
I think it would.
Depends on how big the box is.
It's 15 degrees.
Depends on the box, depends on the forces
The
that's
angle.
happening within it, how much the mass of the book is. All of this is playing into this, but this is the thing. Right now, I haven't told you whether the book's moving or not.
Yeah.
So at this point,
So
we're
it's
going to go
moving.
as if it's not, and we're going to stick with static friction. Now, here's the good news.
Huh.
One of the first lessons you learned in this class still applies.
Once you learn it, don't forget it. Always forget it.
New S. What did I teach you about your reference?
It can be different.
Change.
It can change, it can be different. So in your whole life, and you're going to love this, prepare yourself. In everything you've done, every math class, you have had everything spelled out for you. That here was your X orientation, here was your Y. This is how it's always been until today.
I don't want.
You can move this however you want. Only the laws have to stay the same. You have to have 90 degrees between all the axes. So we can turn the whole axis,
Upside
I don't know, let's say we just rotate it 15 degrees.
Exactly.
I don't like this.
To where now our reference point, we have our axis like this. There's a purpose behind this. So you can change. Let's do the blue. That's our x-axis. Let's do a y-axis.
Now, can we stop this with trig?
This is why we're turning the axis.
With trig or without trig?
We're going to use trig.
Okay, so this looks like trig.
Because if we left it the way it was,
Yeah, you
then the force of gravity would have fell on the y-axis. What is the force of gravity equal to? You guys are used to this. Mass times gravity.
Sure.
So if I tell you we're on planet Earth and I give you the mass of whatever object sitting on there, you automatically can solve for that.
9.81.
But let's say you got to figure out normal force. Right now, force of gravity and normal force are no longer lining up with each other.
So
But you can easily solve for this. Since we can easily solve for that, that is not on the axis. So that would be what we would like to call a resultant vector. What can we use the resultant vector with?
Pythagorean theorem.
So we can look at and we can break this apart.
Oh.
I yell about half the day, so my
It's
voice is
okay.
hurt.
Yeah.
So I can put here,
Or you can do the other one.
and have you?
Wasn't Mr. Ames talking about the Pythagorean theorem today?
What?
This morning.
I don't remember.
Because we have to have one, like what's the resultant vector? What makes up a resultant vector? X and Y component.
Oh,
Whoa.
Yeah,
Currently no
no
signal
signal.
makes up.
No physics today. Shame.
Sucks.
That's a deal with people.
Tech day.
Tech fixed. Hit the power button. Tech day done.
Oh man. So,
That doesn't
how
always
do you
work.
press the power button?
Okay, so in this, we have this one coming here. Which axis is that on?
Why?
The y-axis. So this is the force of gravity
Let's do
in the y direction.
Oh, hold on. I missed it.
Why did you put a triangle there? Where
it. You did.
Because
what?
we're going to use trig to find these components.
It's like in this
Okay.
article when she discussed the perpendicular even though it didn't exist.
So now this purple here, this is the force of gravity in the x direction.
Huh?
Give me a second so I can redraw all this, because I did not make this big enough.
I just need different color pens like you got.
That sucks. He told us. He gave us the syllabus at the start of the year that said, get colored pens.
Actually,
You didn't read it.
I don't think
Okay, so
we
here
got the syllabus.
You want me to pull it out?
I will
Yeah.
give you a second. Okay? Answer your question. I know right now you feel overwhelmed. Like, why am I doing all this? Why am I breaking this in components? I'm doing this because this gives us answers to other pieces. We can draw relationships now. If we just leave it as a resultant vector, it's not going to help us.
You know what popped up in my memories not too long ago? You remember last year we were talking about single replacements in chemistry, and I made that picture where it was like the guy and the girl holding hands with the guy looking back.
Yes. Yes.
That was so funny.
So, does this apply with like,
Science.
never mind, I'll just see how this turns out.
That's one thing I learned in chemistry is just wait till it's over, because you'll probably answer the question.
All right, so in this, perfect example. Is the book following through the ramp?
No.
No, which gives us some
I hope not.
information. Like something you guys have been used for. Used to. There we go.
Definite.
I'll find the words. The net force was equal to the summation of the forces, right?
Mm-hmm.
But you were only in the one direction.
Mm-hmm.
Now you have to realize for net force, you have two separate ones. You have a net force in the x direction and a net force in the y direction.
Will this be on our quiz?
That's what I was about to ask.
No,
Our quiz is just.
1D motion's the quiz.
Well, we have that like velocity light junk on there, or are we just gonna have the other stuff?
Y'all want to tell him or should I?
I've asked this like 10 times.
Verb, once you learn it, don't forget it, and all is fair game. It
That
sucks.
doesn't go with my study habits.
I know it doesn't, but
It's,
it is what it is.
sorry guys, we're not getting that 75.
Okay, so in this, you can only add x components with x components and y components with y components. This is important. This gives us the ability to piece everything together, because then what we can do is we can find the net force in the x direction and the net force in the y direction. And what are x and y components good for making? That is also known as our resultant vector.
Sure.
So we can use that information
Parabolas.
to figure out a lot of things. So in this, let's say I'm looking that I want to hang a sign. Okay, if I want to hang a sign and I have all these different cables pulling on it, I look at how much force all of them are pulling on. I find what the net force is, because these are the components. I use the components, find out what the net force is. Once I find out what that net force is and the angle that it's at, I just have to take a 180 of it.
Uh-huh. The opposite.
Yeah, it's the opposite.
Okay.
Yeah,
Why didn't you just say so?
I know. I made it complicated.
Take the 180.
You just moved the decimal.
No. You'll multiply. You'll move the decimal.
All right, so in this case, like looking at what's on here for the net force in the x direction. So I have the force of gravity in the x direction, because it's down here. I know you don't see it up here, but it's down here, and it's still on that x-axis.
So, what's that word? It's like when you got all the shapes in your. Oh my god.
A rhombus.
No.
Rhombus is a shape, yes.
No, it's like you got the thing. You got like all kinds of lines going all over the place, but you get like a corner here. You get like the angle here.
That's
Oh,
what I was trying to
complementary,
say.
Composite.
Complementary angles, stuff like that.
Yeah.
So that's a complementary. Yeah.
You're going to use all of that. That's why it's important for you to have all this math when you come in here. Okay, other thing going on in the x direction. We have force of static friction. Now, in this, that's everything happening in the x direction right now. The only thing with it is, I don't know whether it's moving or not. This right here would tell me whether it's moving down or up the ramp. Here's where everything becomes very interesting. What is static friction equal to?
It is less than or equal to I don't know what mu K means. I don't remember.
It's a static friction coefficient.
Yeah, static
Times?
friction times the the normal force.
Times the normal force. Where's the normal force? The normal force is in the Y. So before I can ever figure out if this thing is moving into X, I got to figure out stuff in the Y. But then on the flip side, if I want you to find out something going on in the Y, I can give you the information for the X and make you solve to get in the Y.
Every bit of what you just said kind of went in one ear and out the other at that point, just because I can't comprehend it. Not that I'm not trying to, it's just...
It's okay. I understand. Like I told you guys, like this is how physics works. It keeps going. You're totally confused. Have no idea what's going on. Have no idea. And then you start figuring it out and you're like, hey, maybe I can do this. And then we add something new to it and you're like, nope, I'm confused.
Yeah.
Yeah, I totally get it. So,
What if we never had that moment of understanding?
you had that moment. We had it last chapter. I seen it and it sparked inside the whole class. I don't care what you say. I saw it.
My 50% begs to differ.
Hey, you haven't took the quiz on one dimension motion. Force, I mean.
Okay, and your point is, so we're gonna start.
All right, so what about the Y direction? So we have the normal force.
And our Y thingamajiggy coefficient, whatever coordinate thing.
Y component is force of gravity.
Yes, that one. Y direction.
Or the
component.
force of gravity in the Y direction.
You know what I was talking about.
Yeah, I got you.
Yeah, thank you.
How did you figure that out?
Science.
Because it's everything going in the Y direction. I broke the force of gravity into its components so I can see how these things are interacting together. The other really cool thing here is, take a look. This is where turning our axis helps. You can find the force of gravity. You can find the force of gravity in the Y direction. Why can we do that? Because we have an angle. You may want to guess what that angle is.
15.
15
How did you
degrees.
come up with 15 degrees?
But it's
Yeah, buddy, I don't know.
It's a complementary angle.
No.
You can do that or look at it this way. What did we do?
Rotated our x-axis.
We
15
rotated
degrees.
the whole Cartesian system, not just the x-axis. The y-axis used to line up like this,
Yeah, you rotated
with
it.
force of gravity. But then we rotate the whole thing
Yeah.
to where it lines up with normal force.
Yep.
How far did I rotate it?
15 degrees.
15 degrees. So we changed this. Wrong angle. We changed this 15 degrees.
I really want to say, this looks a little funky.
I know it's a big globbed up mess.
No, it don't matter what side it's on.
No, it does. That's why I had to change it. I made a mistake.
So what are we looking for again?
It
Hold on
depends
a
on
minute.
what you're given and what
Wait,
you're asking
what?
for.
No, wouldn't it be right there since we
No, the bottom one would be the 15 degrees.
Yeah.
Yeah, how would it not be?
Because you're looking
Here's the
at
point
I see.
that I turn it on.
I see.
Yeah.
Okay.
You're starting with that red line and you're going over to
The green one.
To the green.
green by 15 degrees because the ramp is at 15.
You're gonna have to clean up your drawings.
I'm just
I want
confused.
you to curse my drawings.
I still don't understand.
Before it's over with, I'm going to get G in here, we're going to get a picture, and I'm going to win an art award.
See it?
I still
I
don't
love
understand
it.
how
I love to see it.
150 or not 150.
The day you do that will be the day I pass in here with 100%.
Okay, when you look here, okay, think about where everything started at, okay? The axis started here,
We know where you did.
on the red line.
Yep.
You know what I mean?
But then I rotate it this way 15 degrees.
Science.
So it goes to the green line. This is the point I rotated on, not this point.
Okay.
So we went like that. We went from here to there, 15 degrees. Just like we went from here to here, 15 degrees, even though you don't see it. That's what we did.
Yeah, fine.
Okay, so in this, when you're looking at this, this is why this works out so well for us and why we did this. Now, make a comparison. Is it falling through the ramp? No. Clearly it's not falling through the ramp. Therefore, we know that the force of gravity in the y direction is equal to, but opposite, the normal force.
What's the normal force?
Well, you have to calculate it.
How do you calculate the normal force?
What is our mass?
You can use that, or you're going to use this identity, because can't you solve that? I gave you an angle, and you're going to have a resultant vector. You can find the force of gravity in the y direction, right?
No.
Do we have a side? And
Uh,
what do we have?
Yeah, you got a resultant vector.
Yeah, sure.
And what else do we have?
An angle.
You need 3, don't you?
No. Trigonometric function.
You already.
Oh,
Matters which one we're solving for. Since I'm solving for f of g of y, boom.
Obviously, we're
That's
doing
adjacent.
so what would be
tangent
the
of 15
result,
degrees equals opposite tangent adjacent
the vector?
tangent of 15 degrees. Don't we need a side length?
yeah. That's what-
Yes, you get f of g. That's the resultant vector. It's a terminology thing, okay? It's a difference in you guys are used to mathematics terminology. You're not used to the science terminology. I'm calling
How
this
do
my
we get-
resultant vector.
What's the vector? Like, what's the number for?
I don't.
I haven't given you one. This is just the notes. This is like breaking it down to introduce you to it.
So f of g
Numbers would be
equals.
very much appreciated.
I'll give it to you. It's mass, like I'll give you a mass. Like this is what I'll do. You'll have to solve for this, but I'll give you the mass to where you can solve for it.
Figured it.
And then it's just a domino effect.
Ribs.
So if you get one thing wrong, you're screwed.
Yes.
Not my terminology. It wouldn't any of them.
Definitely will hurt your cause of trying to.
Okay, so say on a quiz or whatever, since it all like kind of links together, if we were to start off and get a number wrong there, would we still get credit for taking that number and doing the rest of the stuff?
Yeah, I'll give you partial credit.
Okay.
I'm not going to hold, like, because you messed up at step 1 and you didn't get the answer at step 7, it's kind of like jacked up. If I'm going to look and say,
Why you just make
no grades for you, 0.
Pass that to Liz. Pass that to yourselves.
Really?
Here you go, sir.
Thank you.
Thanks.
Here's mine. Mr. Hall already had one.
Any questions?
Ratio.
This is gonna be put up tonight, right?
Yeah.
Good.
I'll be studying.
Are we gonna be going over this on Wednesday?
No, please don't go over this on Wednesday.
You will be working problems with this, not at race. That'll be one dimension.
Okay.
And your quiz, like this new stuff is not involved on your quiz.
Okay.
When,
Then
when,
Thursday,
when is our quiz?
It's Thursday.
then can we take Wednesday in here, like in class, and do problems too for one dimension? Instead of working on something else?
Okay, I have a question.
When are we?
Refreshers.
Is the force of gravity, Fg, the same as the force of gravity in the y direction?
No,
Fgy.
no,
No?
Probably not the same.
because it's off at an angle. This, if you look at it, if that and that is equal, it's impossible.
And then, so we'll have to get the force of gravity, and then we'll do the
All of these
angle.
things I'm showing you, there's a reason, and this is why it's so confusing to you. You're not used to seeing expressions for values. You're used to seeing values and then like one expression, and you solve to get that expression. In this, I'm showing you everything I'm trying to explain to you everything that's happening in this situation, and I'm labeling it out with expressions for what it is.
Yeah, I get
So
it.
I'm not giving you a number for force of friction. I'm not giving you a number for force of gravity. I'm not giving you a number for force of gravity in the x direction. I'm not giving you a number for force of gravity in the y direction. I'm not giving you a number for the normal force. I'm not giving you those numbers. Why? Because if I start trying to create these numbers, it's going to be a really big headache and confusion to make sure everything's staying equal and works out.
Yeah. So essentially what you would do was give us like mass, and if we're on Earth, then we'd have mass times
Exactly.
9.81 meters per second. We'd get the force of gravity. We'd have the angle. You'd give us angle, right?
I'll give you the angle.
Okay, we'd have the angle.
Or I'll ask you to solve the angle. Either way, I will have enough information there for you to work and solve to get to it.
Yeah. And so we would take like the force of gravity and the tangent of 15 degrees. No, not the tangent. The adjacent over hypotenuse. It's
There you go.
cosine.
There you go.
Cosine of FGY, which would be 15 degrees. So yeah, so on and so forth.
And so then in that you're going to solve for that side.
And then eventually you're going to get FGY, and then you can also
from
solve
FGY, you now find normal force. And then
Force.
from normal force, you can find the
That.
force of friction.
with
From the
that.
force of friction, you can tell whether or
That.
not you can answer.
And
we can find force of gravity in X direction.
You can
It's
do the
happening this
Pythagorean
way.
theorem with
We can tell,
that,
is the
that,
box
that,
moving? Is it not
that.
moving? Is static friction keeping it from moving? Yes.
When will we be
You'll have
working
normal
on
force
problems
and
with
you'll have-
this? Like, when are you gonna start doing problems with this?
Probably tomorrow, because we still, this
Good.
is just force. We need to go to motion and 2 dimensions.
What if we got thrown out of school again?
What?
So what if
What-
we got
what if the
thrown out of
teachers
school
go on
again
strike?
on like the 13th?
It's not happening.
What if Jim Justice removes the mask mandate
One
and
good
all
parade.
teachers go on strike?
Didn't Texas do that?
Yes.
Yeah.
Didn't we talk about that yesterday?
And Iowa.
Alright, so
And North Dakota.
those are forces. I understand you're confused right now, but this is the part where if you're going to sit here, you're going to get frustrated with me, and I'm reading y'all's body language. You're just going to get frustrated with me and get mad at me. You ain't helping yourself. I understand it's confusing. That's why I teach this the way I teach this.
I'm not mad at you, I'm just mad that I'm dumb and I'm.
You're not dumb. You guys are not used to seeing this. How many of you in this room have ever sat and all you got in something somebody teaching you were a bunch of symbols? Never till this class.
Does Spanish
But-
count?
Oh, that was good. Oh, I love that. Okay. In this is all new to you. You guys have never done this before, okay? Just like my freshmen. They're going through some growing pains of Mr. Hall has high standards and he's never going to lower his standards and he's not going to tell you what's on the quiz. Even though
What you
every
learn?
day of my life they're like, what's on the quiz? Well, what are you going to ask us? What's the questions? Can we get a study guide?
When'd you learn it? Don't forget on
And I don't do that to them because they ain't ready for that. If I did that right now, I'm dead. Like,
Yeah.
I'm going to be dead.
No, you won't
Trust
be
me, these
dead.
freshmen,
They will be.
they are going through some growing pains. Why? Because what have they been trained to do? They give them the study guide, which is the quiz, and it just says study guide on it.
I remember
And they
this call.
memorize the answers. We put the test in front of them. They puke that out on a piece of paper to me. They get an A, and it's like, oh, you're so smart. You're so brilliant. And then it's like 3 weeks later, they can't tell you nothing. So now what are they doing?
Okay.
You know me. My standard is I'm never going to tell you what's on the quiz. Never. You're going to have I'll answer your questions.
Yep.
But I will never tell you what's on the quiz. So now they're struggle busing. And now they're facing the growing pains. And it's like you all. You guys have never had this before. This is something totally different to you, so now you're struggling with it.
Hold on. I remember this exact same talk from sophomore year. In honors biology, the class you hated.
Just leave it alone.
That class was fun.
We
I
cut
don't think I
Me
really
and you
remember.
have two totally different definitions.
Remember,
We
hey,
took
remember
an
when we cut
egg
up the
and put it up in
sharks?
front of that. I remember doing that.
then we cut up the sharks,
Yeah, the sharks. I
Okay.
remember.
and we were gonna do like the sheep eye.
I say we don't do
Right.
anything else so I can let my
Right.
brain soak this in.
Okay, so that was force. Now you see why friction's so hard. That was force. Now we're going to go into motion. You want to grab a picture? I don't care.
Yeah, I will. Anyway, maybe hold on.
Do we have a group for this class?
No,
Well, there's 7 of them.
But we will.
8 including me.
No, there's a Snapchat group.
You have Snapchat? You want to join?
No. No. First off, I don't even remember my login for my Snapchat. Ain't been on that in years. And second off, I definitely, like, that would be a mess and a half.
Oh, yeah.
Mr. Hall, why are you on kids' Snapchats? Like, woo, no way.
At you on our story.
One of our group chat, was it our AP Calc group chat?
Yeah.
Was it before that quiz or something? I don't know, something was coming up and we knew we weren't doing too good. And
Ethan Waldron, report to
it
the office,
evolved
please.
into how we're gonna have a business digging graves.
Yep.
Because they make a strangely good amount of money.
$300,000
I like that catch.
Who does?
Grave diggers.
$300,000 to dig graves?
That's
Yeah.
the one to dig my mama's grave, how much he made.
Good God.
Wow.
Yeah, exactly.
You know, see me get a custom shovel, a grip on it.
All right, so in this, so now we've done forces in 2 dimensions. We need to look at motion in 2 dimensions. So in this, everything will be the same, like wording will be the same to you, but things are going to be different. So let's say that I give you a problem that Connor is throwing a football to Logan. And he throws the football with an initial velocity of 5 meters per second. We'll just keep it simple. But he did this at an angle of 37 degrees.
Now, would you care to,
You know the exact angle, well, the degrees of an angle that you throw a football at?
I know what
You're
you
talking
need to
about.
aim for. If you want to get the longest, you're going at 45. You'll learn why. Okay, so then we have the initial velocity here, which is equal to 5 meters per second. Now here's the thing. In this, it's just like it was with forces. Because velocity is a vector, force is a vector. So guess what we can do with it? We can make component vectors, which builds what?
A graph.
It makes them all axes.
Okay, that's X.
A triangle.
That's a red line.
So that's the initial velocity in the x direction.
No, we gotta turn it.
No,
Wow.
you don't have to.
because you're already on the flat, whatever.
The land is the flat point. I don't want to turn it in this case. The reason we turn the force
Because we're on
is so
the
something lines up. If something lines up on an axis, then the number you're given, that's the number for it. There is no component. So this is the initial velocity in the y direction. So now in this, we can find some information out.
Yes.
Like, for example, we could find the initial velocity in the x direction. Because whenever we look at this, we would look and say, I'm trying to find this. So in terms of this angle, that's the adjacent side. So which trig function uses the adjacent side?
cosine.
So we have the cosine of 37 degrees is equal to the adjacent, which is the initial velocity in the x direction, over the hypotenuse, which we know is 5 meters per second. So we can now readjust this thing around to where we get the initial velocity in the x direction to be equal to 5 meters per second times the cosine of 37 degrees.
How did we get time? I thought it was over.
It is. That's division. So now I'm trying to get v.
You're trying to get the initial velocity in the x direction by itself.
So you got to multiply by
So
5.
you would multiply to get it away.
But can't
Like you were trying to
Well, class is over.
Hey, in this, I do want to stress y'all, make sure, like in this class, we're not going to deal with radians. So make sure your calculators are in degrees. Because what I get is 3.9931 meters per second.
Forget how to check to see if it's in radians or degrees.
Up at the top, it'll tell you. It's the second,
Gotcha.
the second from the right.
You should just spend your planning period making sure all those calculators are A-OK.
How do you change it?
Go to mode.
Oh,
Once you hit mode, on there you can come down. Oh, snap. Mode.
where's mode?
It's right next to the second function.
Can I ask a question?
Yeah.
Would velocity initial y be 3.0092?
I don't know, it's coming right. But you go down here, if it's radian, it's highlighted there, you just go over to degree and hit enter. And it'll change it.